solve for standard deviation within the z-score formula. So we know the z-score formula is z equals x minus mu over sigma, or the z-score equals the value minus the mean all over the standard deviation. Now, oftentimes we think about this formula when we know the value, the mean, and the standard deviation, and we're solving for the z-score. But sometimes you're given other values, and we need to be able to solve for whatever we're missing. So, in our example here, we're given a data set with a mean of 18. We know that a value of 24 yields a z-score of 0.8. What is the standard deviation? So again, let's start with our formula. We know that z equals data value minus the mean over the standard deviation. And what do we know? We know the mean is 18, our data value is 24, and the z-score is 0.8. We need to find our standard deviation. So let's substitute our values in. I've got 0.8 equals 24 minus 18 over our standard deviation. I'm going to use an S because sometimes sigma looks a little bit like a 0. Although, I guess S sometimes looks like a 5, so I'm going to actually get rid of that. I'm going to just use T, okay? Just because that's kind of a different one here. All right, so if we're trying to solve for the variable in the denominator, that's not generally a great thing. So our first step is to move that out of the denominator. Now, we know when we have an equal sign, we can do whatever we want to one side of the equal sign as long as we do the same thing to both. So if I multiply the right side by t, that means it's like multiplying by t over 1. These are going to cancel out. But to be equal, I have to multiply the left side by t as well. So I end up with 0.8t equals 24 minus 18. Well, I know 24 minus 18, so let's go ahead and do that. 0.8t equals 6. Now, to get the t by itself, we must divide. Because right now, 0.8, if it's touching t, that's like multiplication. The opposite of multiplication is division. So if I divide both sides by 0.8, those cancel out, and I'm left with t equals 0, oops, I lied, there's no 0 there, just 7.5. So my standard deviation for this particular problem is 7.5.